Good morning, all. This is the model question paper of Engineering Visualization 2021 scheme, set 1. So, in this, we need to answer all the 4 questions. So, you can see question number 1, question number 2. Okay, question number 1 consists of points and lines. Question number 2, solids. 3 is orthographic, and 4 is development. So, first I am going to solve this points problem. You can see in this question, first I'll be drawing an XY line. Okay, I'll be taking thickness of 0.25 mm here. I'll draw XY and font size will be 5 so that the fonts will be visible to us. So later on you can delete that VPHP. Okay, initially just I'm writing it. You can see in the question, point 20 mm above XY line is the front view of 2 points E and F. That means above the XY line I'll be drawing thin line of dimension 20 mm. Okay, give the dimension 20, and here exactly at this end point I'll be putting the point by taking thickness 2 mm. So put the point, go to smart dimensions. So and now you write E dash F dash. Okay, this is your front view, E dash and F dash. Okay, now you can see the top view of E is 35 mm behind VP. So 35 mm behind VP means two chances. Either the point top view can exist in second quadrant or in the third quadrant. Both the top views are lying above the XY line. That is, HP will be lying above the XY line. So that means I will be extending 15 mm above of it. So give 15, enter. So draw the straight line, exact straight line here. Okay. Take the thin line and give 15 mm. 15 plus 20, it will become 35. Okay. You can extend it and show the dimensions here for the XY. So it is 35. Now you can go to point and select the thickness of a point, it is 2 mm, and put it at the end. So this is what your top view. Okay, now the top view of F is 40 mm in front of VP. So the top view in front of VP means two chances. The top view can exist in first quadrant and fourth quadrant. In both these cases, top view exists below the XY line. Okay, HP will be lying below the XY line. So I will be drawing 40 mm below the line, below the XY, and here you can put a point here exactly at the end point by taking thickness 2 mm. Okay, and show the smart dimension. Okay, now you can write this is your top view of F. Okay, so that completes the points problem. So you can subscribe for the channel and hit on the bell icon for the latest notifications. You can share it to maximum students. You can see we need to write the in which quadrant they are lying. The E is lying in second and third quadrant. Okay, E is lying in second and third quadrant, and F it is lying in first and fourth quadrant. First and fourth quadrant. So subscribe for the channel and hit on the bell icon so that it will be helpful for you people. Okay, you can see that we have completed a points problem. The same way I'll be doing this lines problem. You can see the question. End A of a line AB is in HP and 25 in front of VP. End B is in VP and 50 mm above HP. That is end locus line distance, and then the distance between end projector distance given it is 65. So using this we have to draw the projection lines here. So here first I will be drawing XY line and I will be mentioning VPHP. So you can easily mention here because from the projection of lines we are using only the first quadrant. Okay, so we can mention XY VPHP. You can take the font size. Okay, you can take the font size. You can mention VPHP here exactly. Okay, now you can draw the locus lines. The first is 25 in front of VP. In front of VP means you can draw in the HP plane. So go to, give the distance 15. You can see that 15 mm, sorry, 25 in front of HP. You can mention that. Okay, above HP it is 50 mm. Go to offset command and select 50 mm distance. Okay, now they have given the distance between the end projector, it is 65. So horizontally on XY line we will take a distance of 65 here. Okay, then we draw a straight line so that both apparent length, top and front views, we get it on the same straight line here. Okay, so from this end I'll be giving a distance of 65. You can see they have given 65 mm. So mention 65 length here. Okay, so just you project it so that we will get to know that. So exactly at these end points we have the weaves of the apparent length. Okay, so for the top end C and A dash we can mention it here. Okay, exactly at these ends. So you can mention here the end points of this line. So here, so we can take the end points. Now you can mention, so that is 65, the distance between the end projectors. Okay, okay, now we'll take thick lines because we know that. So this is the apparent length, what here we getting it. Okay, so I will be drawing two lines. So now you can see here we'll be mentioning the naming of it. So this is A. So with respect to the question, I'm mentioning it. So A dash and B dash. So these are the apparent lengths we should mention. And AF line is on XY and 15 in front of 25 in front of VP, and B is on XY and 50 mm above HV. So these are the apparent lengths. So by rotating these apparent lengths, we can get the true lengths here. Okay, we will measure this A dash, B dash length and rotate. Okay, so take this line and cut the arc. So we need to take from the downward side so that we can able to cut it exactly the length. Okay, sometimes you will not able to get it exactly, so you can try it. Okay, yes, so by cutting the arc, now we'll take the thin line here. So cut the arc here. Now go to line here. For the true length we should select the thin line. So from this end point to this A dash end we draw a straight line. Okay, I'll make this arc as thin. Okay, so now you can mention the naming of it. This is your B2, AB2 true length. Okay, now the same way I'll be rotating AB. Okay, I'll be rotating this AB. Rotating this AB and then project upward with a straight line, so that we'll get the true length here in the front view. Okay, here we'll be joining it. Anu. So this is V1 dash. So you can measure all the dimensions of the both apparent length and true length. Okay, and measure the angles, true length angles and apparent angles here. Okay, so that completes the problem here, lines problem. Actually, it is similar to your problem number 48 in the solution book. Okay, subscribe for the channel and hit on the like button in the for the latest notifications. Okay, now same we will be constructing this. You can see the question number 2. It is a solid problem. In this problem, a pentagonal prism dimension 30 mm side and height 70 mm rests with a corners of a base on HP such that an edge of the base containing that corner on which the prism rests is inclined at 40 degree to HP. The axis of the prism is inclined at 30 degree to HP and 45 degree to VP. Draw the top and front views of the prism. You can see in this problem they have given 3 angle of inclination. So this kind of problem you are not going to see in your solution book. Okay, this is somewhat different. Okay, I'm going to solve this. Okay, so first we have to draw an XY line. Okay, first we have to draw an XY line and we have to take an angle line of 40 degree. For that angle line 40 degree we have to place that pentagon with respect to that base corner. Okay, that's what the concept here. It is similar to your development problems. You can see that okay, you can mention XY VP HP. So mention VP HP. So this is what we have first quadrant. You can see we have to draw an angle line for an angle of 40 degree to HP. So so you can give minus 40 degree angle. Okay, so take pentagon dimension and take 5 sides using polygon by center. Okay, so first you can give the dimensions, exact dimensions, and then you place it on the triangle line. Okay, that will be good because so if you place it like this before changing the dimensions, after you change the dimensions it will change abruptly. Okay, better first we give the dimensions and then we are going to change the things here. So it will change abruptly. So what I'll do is first I'll be constructing the pentagon outside with the exact dimension, and then I'm going to place this with this base edge. Okay, okay, so again I'll construct. So construct pentagon with dimension 30 here. Okay, now you select it and change the thickness to 0.50 mm and go to move command and select the corner point here and then place it on this angle line. Okay, and make sure this base edge containing the corner, so resting on this angle line. Okay, okay, so that's what 40 degree. So I'll be showing for this base edge the dimension of 30. Okay, now we'll be drawing at least I'll draw 3 median lines here, sorry, perpendicular bisector, to find out the center of this pentagon. Okay, so you can mention the naming here, top view and front view. So you can mention A1, BP1, Okay, so now we can mention the namings for the both top face and the bottom face. EE1. Now we can mention the center of the axis, that is O1. Okay, now draw the projection lines. So for the projection lines, take the thin lines here, thin lines, draw from all these base corners and top face corners. Okay, so draw, make sure you drawing a straight lines here. Okay, and here height they have mentioned it is 70 mm. So first I'll be drawing an axis line for a height of 70 mm, and then I'll draw the rectangular face here. You can see they have given height of 70, and this problem also you are not going to see in your solution book. Okay, okay, now we construct that rectangular face here by considering all the dimension as 70 mm here. Okay, so the front view here we have, that is 70. So you can mention all the lines here. The front view you can mention it. Okay, you can write down the front view notations now. So the top face notations: A dash, B dash, C dash, D dash visible. The only the corner end not visible, it is E dash. Okay, and O dash also not visible here from the front view. Since we have missed one front view line, that is from E to E1. Just project it and then you can connect, so that we will draw a straight line here. Okay, so you can mention it is, this is E dash within bracket. Okay, and this is our O dash, that is also in bracket. The same way I'll be writing the bottom face notations. Guys, you may be thinking that why I'm not did the problems in sketchbook, because we know that in the examination the majority, that most of the, that is 85 to 95 marks were there in the doing in system. That's why I'm did all these problems in software. Okay, so it will be convenient for you to follow the same thing. Okay, you can understand that, because for the sketching it is very less marks. Okay, if you want it I can do the sketching, but I'll be doing later. So show the dimensions. Now select this front view, and here inclination, that is axis of the prism, is inclined at 30 degree to HP. So here you can select it. You can select this prism, go to creates a copy, drag it along the XY line. Okay, then go to rotate and select these base heads. If the angle it is 30 degree, so we have to give an angle of 60 degree here. 60 degree we have to give, because it total 90 degree, so we have to give an angle here, angle of 60 degree. So here the angle you have to give, that is 60. Okay, 90 minus 30 means it is 60 degree you have to give. So you can just extend and see the angle. Actually the angle we have to give here for the base axis, it is 30 degree. Okay, so that means I'll be giving the angle again. You can see 30 degree to HP axis of the prism. So I'll be selecting again. Okay, go to rotate, and here you give the angle 60 degree. 90 minus 30 also you can give. So base head inclination, that is 90 minus 30 means 60 degree, we have to give the angle here. Okay, 60 degree. Okay, now we can extend the axis. I can extend the axis and show the angle, measure the angle using angle between command. Okay, so for drawing the final position, I think the space will not be adequate, so I'll be selecting this second position. So using the move command, okay, using the move command, I'll be dragging along the XY line. Okay, now you just project it downward to complete the second position top view. So first I'll be constructing the uh, bottom face. Okay, you can zoom it to get the exact point here. You can zoom in exactly. So draw the projection line. So drawing the projection line from all these ends. Okay, so draw the projection lines here also. So you can subscribe for the channel and hit on the bell icon for the latest notifications, and share it to the maximum students so that they can be benefited from this. So this is a solved model question paper set 1 of the engineering visualization subject, scheme 2021. The same way I am drawing the projection lines for the top face also. You can see it, we can zoom it to get the exact end point here. Okay, so draw the projection lines from all these end points here. Horizontally also we will be projecting the lines here. Okay, horizontally also from this projection, by drawing the projection lines here. So from the center of the axis also we draw the projection lines here. Now we have to write the notations here. Notations, so you have to write it properly. First I'll be writing for this bottom face, that is from A1. This is where A1 I'm getting, and this is where B1. You can zoom in and write down the notation properly. Okay, this is where C1 I'm getting, and this is D1. Okay, and this is over E1, and this is where I am getting the O1 point. And this is our A, and the B point, C point, D point, and E. Okay, you know the concept it is same. So after writing these notations, first we have to draw an outer boundary line. Okay, first step. Second step is drawing the visible faces and visible edges, and third step it is writing the hidden faces and the hidden edges. So first we are constructing an outer boundary line. I am starting from A1 here, from A1 to B1. Can connect, zoom in and connect to get the exact point. And this is where C1 we are getting, from C1 to C. Okay, then from C1 to D we have to connect. Okay, then from D to E we have to join. Then from E to E1, from E1 to E1. Okay, that is what outer boundary line it is constructed. Now visible faces, from the top face you can see that the top face it is visible. Okay, so we construct the top face here. So we're getting a pentagonal face here. So just connect it with the continuous line. Okay, and the rectangular face was also visible, that is A1 and B1 it is visible. I'll be drawing it with a straight line. Okay, from here, from B to B1 also a straight line. Okay, now you can see the bottom face not visible from the top view. I'll be constructing the part of it. Okay, I already have done a part of it with the straight line. A part of it I will be constructing with the dashed line here. Okay, from D to that's what the D1 dash not visible from the top view, that is also dashed line. You can construct this pentagon. Okay, dashed line. Okay, think everything is constructed here. Now finally there is an axis from O1 to O. Okay, this is an beta angle problem because the angle of inclination they have mentioned with respect to the axis here. These extra lines I am going to remove it by using the trim command. You can see using this trim command I am removing all these extra lines. You can see the question in this they have mentioned axis of the prism is inclined at 30 degree to HP and 45 degree to VP. That is, both the inclinations were there with the axis, that's why it is beta angle. So first I am drawing an angle line with respect to VP, that is 45 degree. I'll give minus 135. So I'll get 45 degree below the XY line and measure the angle, it is 45. Now, so here there are two axis lines given, one is 70, another one is second position top view, we have to measure it. Okay, that is 61.51. The first axis length it is 70 mm. Go to arc by center, take a reference point, anywhere here, yes you can take it, and you cut the arc for 70 mm. Give the radius 70 and sweep. Now here at this cutted arc point, so we have to draw an locus line here, straight horizontal line. Okay, again we have to go to arc by center and measure the length of 61.51. Just you touch the first arc, you will get the reference point. Just move the cursor over first arc, you will get the reference point. Give the radius 61.51 and cut the arc, sweep it. Now you join this second cutted arc point with the reference point. Okay, and then you extend using extend to next command. Okay, extend to next command. So measure the angle. So the angle you are getting here 54 degree. This is what your beta angle. Now select the second position top view. Go to move command, creates a copy, and say here you have to select the axis here. This is what important thing. Select the O point here. Okay, place it on this reference endpoint. Then go to rotate from this reference point of from O to O1. Rotate it. Okay, keep at the reference point. Done. Now you draw the projection lines. Okay, so construct the projection lines to finish the final position. So here the projection lines I am drawing for this top face. So draw the projection and consider the top face from A to A dash. Draw a straight line so that you will get a dashed line here. Again from B to B dash, there is a dashed line. Okay, the same way from C to C dash also you should draw the projection line. You can see there is a dotted line appearing it. So this is where we have to end it. Okay, so it will avoid the merging of the lines. Okay, you can get the exact endpoints here by doing like this. Okay, from E to E dash you just touch it over and bring it back, you will get the dashed line, and this is where you have to end it. Okay, the same way we have to write it for the O dash. Okay, just move the cursor over and bring it back. Okay, that gives O dash. Okay, it is I think little bit upward, so just I'll move it again and bring it back. Okay, that is what O dash. You can all write all the notations, so it will avoid the confusion. So you can write then and there, so it will be helpful. A dash, B dash, C dash, D dash, and E dash, and O dash. So the top face notations are done. Top face notations are done here. Okay. Okay, in the same way we write the projection lines for the bottom face here from A1 to A1 dash. Draw the projection line. So touch it and bring it. Okay. So just you move the cursor, touch it, zoom in, so that you can get the exact point where you want to exactly end it. Okay. So that is your A1 dash, which you can mention it, so that you can mention it, the naming there only. Okay, the same way you can do it for the B1 dash also. The same way you can write it for C1 dash, D1 dash, and D1 dash, and D1 dash. Same way you have to do it. Okay, you can subscribe for the channel and hit on the bell icon for the latest notification, and hit on the like button and share it to the maximum students so that they can be benefited from this. In the same way you can write down the notations and the projection lines here. Now we have left with E1 dash. Okay, same way you mention the axis notations here. Okay, so here we are getting O1 dash. Okay, now you can see here for writing the final position we have two nearest points here, that is E and D. Okay, so that means E, D, and E to E1 dash, D to D1 dash, E to A dash, and D to C dash. So this will be your dashed line. First I will be constructing from E to E1 dash using dashed line, then from E to okay, to A dash, E dash to D dash, now the remaining lines you can construct with the dashed lines, continuous lines here. And finally there is an axis. can construct it. Okay, now you see that question number 3 is your orthographic projection. Using first angle projection, draw front view. You can see that is your question number 3. Okay, top view and right side view of a machine component as shown in figure Q 3.1. So looking at that, they have given the isometric component of the machine. Using that isometric component we have to draw. So here we have to go to the ISO part. So for doing in system we have to go to the ISO part here, select base reference lines, go to synchronize, right click on it, click on transition to ordered. So you can see here, so here they given front view, top view and side view. I'll be selecting the top view using extrude command. Okay, go to extrude and select the top view. Okay, now you can see here the rectangular length, it is 20 plus 36 means 56. So from the center, 26 means I'll take here 56 means 28 this side and 26 this side. Okay, that will give 56. Okay, so you can see the top view. Okay, so in the top view the length we have to give, that is 15 we have to give. Okay, and then same in 15 from here also. Okay, so here it is again 12. So another side we have to construct by 12. Here also from this end also it is 12. Okay, now we will join it with the help of like where it is there, and then I will change the dimension. Okay, using smart dimension, and I will change it. Okay, so select this, you have to change it to 20, change it to 20 mm here, change it to 20 mm. Okay, so here the distance between these two lines, it is you can show the dimensions here. This is 12. You can see here the 16 mm is the distance between the 20 mm line and the 12 mm line. So using distance between command, I am going to measure this distance. I am going to change now, change into 16. Okay, you can see that here it is 56 as per the dimension in the front view. Okay, that completes the top view notation. Now, so we click on the close sketch. Here it is extruded from both sides. The thickness we should consider, that is 8 mm. You can see that. So 8 mm distance you click, type and then click, and then you have to click it on the finish. That will finish the machine component, but there is an extrusion exactly on that center of it. That extrusion we have to construct. You can see that 15 mm height, 14, and then for a total length of 24. So I'll again go to extrude and select this plane. Okay, so using this side view I'm going to construct. You can see the diagram. You see this is the side view. So here, from here I'll be considering a height of 15 mm, 15. Okay, then 14, and from here bottom the length, it is 24 we should consider. Okay, so 24, and then you can join here. Okay, okay, just you check the dimensions, here. Yes, as per the dimensions we have constructed. Now close the sketch, and here thickness you can see in the diagram. The thickness here also, it is 8 mm. It is extruded from the center, 8 mm. So that finished the sketch. Okay, we have completed the machine component in ISO part. Okay, now save this you can give that file name. I'll give this file name as machine component. Okay, machine component, and save. So after saving it, we have to draw the orthographic of it. So go to here. So in the new we have to go. So go to new here. You can see here we have create drawing. So click on this create drawing. You have to click on this create drawing. So in the new, then click on this iso drop. Click OK. And here next, and here you can select custom. Okay, then close. And here you have to select top view, front view, and right side view. Okay, that is your top view, ISO, and right side view. Click on the finish and click here. You'll get all the views here. You can see ISO, top view, front view, and right side view. Now I'm setting the sheet here to A4 because we have to take the printout in A4. Okay, click OK. After making the sheet as A4, now drag all these parts, top view, front view, and right side view within the sheet. Okay, so you can give the dimensions here using smart dimensions. We just check it whether we have constructed exactly or not. So this is what the orthographic view of the isometric. You can see we are showing all the top view, front view, and right side view, and the isometric component also we have shown there. So I am just showing all the dimensions as per the diagram. Okay, you can see top view, front view, and right side view, and there is your isometric component. So I think that completes the problem. So you can subscribe for the channel and hit on the like button for the and hit on the bell icon for the latest notifications, and share it to maximum students. Okay, now we are going to complete the problem number 4. Problem number 4, it is an inclined tray. Okay, so you can see the dimension. Draw the development of the tray whose top view and front views as shown in figure Q4.1. Okay, as per this top and front view, I have constructed already the top and front view. So you want to know how to construct this, I have done already one video on it, development of an inclined tray. You can see there how to construct the top and front view. After constructing this top and front view, I'll go to the arc bisector and measuring this from A dash to 1 and cut the arc. Same way you have to do it from C dash D dash to 3 4 dash. Okay, cut the arc. Now you project the lines here, straight line. After you cutting the arc, you just have to project the lines downward from these both ends. Okay, now from this A, B, C, D endpoints, so we have to draw an horizontal lines touching these projection lines. Okay, and you can say that that is from 1 to that line we have to draw an projection line. Okay, so that we can able to connect it. First I will draw this horizontal projection line from this 1 horizontally, and from this 4 also, from this 2 also, then from there 3 also. Now we have to join it. Take the thick line. Now you join from this D to this intersection point. Okay, connect it. The same way you can do it from this A point to this here. Okay, the same way from this B point to the intersection point. Next, from this C point to this intersection point, now you connect this with the vertical thick lines. Okay. Now by taking this lens, we have to cut the arc. So we have to cut the arc from this, taking this extra length what we are getting, right? By measuring this length using arc by center, we have to cut the arc on these projected lines. So I'll be extending these lines little downward so that it will be helpful for us to cut the arcs. So go to arc by center. So measuring the length from this end till here and cut the arc. Yes, this is where we have to cut the arc. The same way like this I will be doing for other end also. Till here we have to stop. Same way from this measuring from this B to this longer length, measuring it and cut on this projection line. The same way from here D to this length you take it. Cut the arc. So measuring this length from here to here and cut the arc. Okay, now we have to join all this cutted arc point using straight line, thick line. So we have to connect it. Okay, so joining all these cutted arc point with a straight line. Okay, now you join here. Okay, from here to here, yes, and then from here to here. This inside lines I will be making it as thin line. Okay, so that it will be convenient, so that we can understand it easily. I will be selecting that inside lines. I will make it as thin lines here. Yes, those lines, inside lines. Zoom it little bit. Yes. We select it. I think I have not joined it properly, so I can join. So you can see that completes the problem. You can subscribe for the channel, hit on the like button and hit on the bell icon for the latest notifications, and share it to the maximum students so that they can be benefited from this. Thank you for watching the video. Thank you all.